Three metrics sit at the center of almost every reliability program: MTBF, MTTR, and MTTF. Most engineers can recite the definitions. Far fewer can say when each one lies to you. That distinction is where maintenance budgets quietly bleed. Start with the fork that causes the most damage. Is the asset repairable or not? A centrifugal pump is repairable. You fix it and return it to service. A single mechanical seal inside it is not. When it goes, you replace it. That one question decides which metric you should even be using. MTBF, mean time between failures, applies to repairable systems. It's total operating uptime divided by the number of failures. If a compressor runs 10,000 hours and fails 5 times, its MTBF is 2,000 hours. But read that carefully. It's an average rate across a population, not a promise that any single machine survives 2,000 hours. Treating it as a guarantee is the first classic mistake. MTTF, mean time to failure, is the equivalent for non-repairable parts. Same arithmetic, different meaning. It's the average life expectancy before the component is discarded and replaced. 6 seal failures across 12,000 operating hours gives an MTTF of 2,000 hours, which tells the storeroom to always keep a spare seal on the shelf. Used this way, MTTF does exactly what it was designed to do. MTTR, mean time to repair, measures something entirely different: recovery speed, total downtime divided by the number of repairs. And here's the detail most dashboards hide. MTTR is not just wrench time. It's detection, diagnosis, waiting for the part, the actual repair, and testing. On real sites, the largest slice of MTTR is often the part that never arrives on time. Put them together and the relationship becomes obvious. MTBF tells you how often failure happens. MTTR tells you how fast you recover. Availability, the number operations leadership actually cares about, is MTBF divided by MTBF plus MTTR. You can have excellent reliability and still post poor availability if your recovery is slow. MTTF, meanwhile, feeds the spare parts plan that keeps MTTR low in the first place. Now the failures. These metrics assume identical parts in identical conditions, but 2 nominally identical pumps running at different loads and temperatures fail on completely different curves. They're also retrospective. A bearing already vibrating at twice baseline isn't in the historical average. And critically, none of them model the supply chain. A seal can have a perfect MTTF and still take the unit down for 6 weeks because the only qualified supplier is on a 14-week lead time. The metric was right, the system failed anyway. So the rule of thumb: use MTBF for repairable systems, MTTF for the parts you replace, MTTR to expose where recovery time really goes, and never use any of them alone to plan critical spares. A static failure rate can't see load, condition, lead time, or obsolescence. Get the definitions right and you make better maintenance decisions. Layer live condition, supplier, and obsolescence data on top of them, the way modern AI-native asset intelligence does, and those same metrics finally start telling you the truth in time to act.